Can a robot truly understand that a chair is for sitting, not just that it's a chair? Current 3D scene understanding models excel at naming objects but stumble when asked about their purpose, material, or other fundamental attributes that define our physical world. Building on that challenge, let's examine why today's models fall short. This limitation stems from how existing benchmarks like ScanNet evaluate models. They test whether a model can identify a table or a lamp, but they never ask whether the model understands what makes that table suitable for dining, or what material that lamp is made from. The authors introduce a new paradigm to address these gaps. The researchers constructed OpenScan by extending existing datasets with rich attribute annotations derived from ConceptNet, a high-quality knowledge base. Each object in a 3D scene is now associated not just with its class label, but with a diverse set of linguistic attributes that capture how we actually understand objects in the real world. This visualization contrasts the traditional approach with the new paradigm. On the left, conventional methods simply map 3D objects to class names. On the right, the generalized approach connects objects to a rich web of attributes including what they're made of, what they're for, and how they relate to other concepts, creating a much more complete understanding of the scene. So how do current state-of-the-art models perform on this more comprehensive benchmark? The evaluation reveals a striking dichotomy. Models like OpenMask 3D handle traditional tasks well and can identify materials when visual cues are obvious, but they struggle dramatically with abstract attributes. Simply training on larger vocabularies doesn't help. The real challenge lies in bridging the gap between visual perception and semantic understanding of what objects are for and how they function. These radar charts paint a clear picture of where models succeed and fail across the 8 linguistic aspects. Notice how performance varies dramatically, depending on the attribute type. The irregular shapes indicate that current models haven't achieved balanced understanding across all aspects, with some attributes proving far more challenging than others, particularly those requiring common-sense reasoning. The OpenScan benchmark fundamentally demonstrates that we've been measuring 3D understanding too narrowly. Moving forward, the field needs training approaches that explicitly incorporate attribute-based comprehension, potentially leveraging large language models to bridge the gap between visual features and semantic meaning. True 3D scene understanding requires models that grasp not just what objects are, but what they mean in the context of human experience and interaction. Visit emergentmind.com to explore the full details of this benchmark and its implications for the future of spatial AI.